Hi there. Welcome to the Chemistry Safety Simulation. Here you will learn how to safely work with dangerous chemicals. Are you ready to learn these skills to save a life? This simulation uses voiceovers. If you don't have audio, click the speaker symbol in the top right corner of your lab pad to switch to play mode. If you disable the sound effects, the lab pad will pop up whenever there are instructions to read. Select the audio setup you prefer. To mute individual audio options, simply select them. Click. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation? This is your lab pad. Use the lab pad at any time to access relevant theory about the lab, or additional instructions on what to do next. You can slide down the lab pad by clicking anywhere on the background. Try it out. Well done. When your lab pad is lowered, you can listen to me without having to click continue. You can interact with highlighted objects. Arrows help you in finding their location. Now click on the corner of your lab pad to raise it. The lab pad will guide you through the virtual lab and store all the information you collect while playing. Click continue to proceed. Make sure you read the information in this white text box carefully. You won't be able to access it anymore after you click continue. You can access all relevant information in the 4 tabs above. Right now, you're in the Home tab. Click on the Theory tab to learn about the 4 lab pad tabs. Use your mouse wheel or drag the gray bar on the right side of the lab pad to scroll down. You can rotate the camera by clicking and dragging your cursor to the side. Click on the background to lower your lab pad and try it out. If you ever get stuck somewhere, you can click me for help. During the simulation, I will ask you multiple choice questions with 4 options. Only one is correct. Let's try it out. What is my name? Click on the Theory tab to find out. Well done. That's the correct answer. When you answer a quiz question correctly, your score goes up. You get 10 points if you answer the question correctly on the first try. For every additional attempt, 2 points are subtracted from your score. This question is not scored. That's why the score in the top left corner of your lab pad is still on 0. The lab pad can also show you images relevant for the simulation. After being shown, they will be unlocked and available in the Media tab. Click the View Image button to have a look at the hazardous symbols that you may encounter in this lab. You can track your progress in the Mission tab. Go to the Mission tab if you want to get an overview of your work or load from a checkpoint. You can also see your progress in the virtual lab time on the top right of the lab pad. Every time you begin a lab, the clock on the lab pad will read 8 a.m. Good job. Now you know how to use all the lab pad functions. It's time to get hands-on. To interact with the objects in the lab, click on them once. Hover over an object to view its tooltip. If an object is out of view, arrows appear on the edge of your field of vision showing you which way to turn in order to find the object. Are you ready to start your mission? Perfect. Then let's get started with your first mission. We just got a new request for a collaboration, so you're right on time to help us out with the lab work. Let me introduce you to the project leader. Click on Marie to talk to her.
Hi, great to meet you. We are planning to grow algae at a large scale in order to produce oils that could be used to create biodiesel.
Would you like to watch an intro to learn about the project and how we aim to produce biodiesel from environmentally hazardous waste streams?
Great, let me show you the exciting project.
Click on the 3D model on the hollow table to teleport to the algae farm.
The residents of a city in Northwest Alaska have decided to make sustainability and natural environment protection a priority. My team of experts have identified the coal power plant and the fish farm as the two main concerns.
Click on the coal power plant to see how it impacts the environment.
The coal power plant produces large amounts of the greenhouse gas carbon dioxide. Click on the glacier in the background to learn how it is affected. The global emissions of carbon dioxide result in global warming, which leads to the rapid melting of surrounding glaciers and ultimately a rise in sea level. Rising sea levels threaten coastal communities everywhere. Now click on the fish farm to your left. The fish farm releases large amounts of waste that lead to algal blooms, ecosystem destruction, and even dead zones in the sea. These two problems are causing great concern to the inhabitants of the city. Now click the city buildings on your right to hear our proposal. We are proposing to build large pools covered with a greenhouse to grow algae for biofuel production. Excess heat and the carbon dioxide from the coal power plant could be pumped into the greenhouse. Likewise, the wastewater from the fish farm can provide nutrients for the algae. Instead of harming the environment, these waste products can be used as a resource for algae to produce oil. We need to find a way to convert this algal oil into biodiesel that can be used to power cars. Let's get started. I came up with a cost-effective method to isolate the oil from the algae. The oil is not very pure, but it might be good enough for biodiesel production. I want you to try to convert this oil into biodiesel. You will use different hazardous chemicals to be able to produce biodiesel from oil. Before you start with the experiment, I want to make sure that you wear the correct personal protective equipment and that you are familiar with the hazard symbols.
First, find a lab coat. Click on it to put it on. Now pick up and wear your goggles to be ready for lab work. Click on the screen to your right to learn about hazard symbols. Click on the symbol that depicts explosive chemicals. Well done. Which one symbolizes an oxidizing reagent? Which symbol would be found on a bottle containing strong acid or base? Which symbol indicates that this chemical shall not leak into the waterways?
It's crucial that you know how to properly dispose of waste in the lab. I'm a scientist because I want to make this world a better place. We need to be very considerate when working with hazardous chemicals.
You can access info about every chemical in its safety data sheet. Click the View Theory button if you want to inspect the safety data sheet for methanol.
Wow, you rock. You seem to be a real chemistry whiz. I'm very confident that you will be able to produce this biodiesel. Let me explain the chemical reaction that we will use to produce biodiesel from the algal oil extract. The algal oil has a triglyceride chemical structure. It has a 3-carbon glycerol backbone with 3 hydrocarbon chains bound to it like tails. To make biodiesel, we just need to remove the hydrocarbon chains from the backbone. We can use an alcohol, in our case methanol, to split the molecule in a transesterification reaction. This reaction doesn't happen spontaneously. We need to add sodium hydroxide as a catalyst and heat up the reaction mixture. If the reaction is successful, it will yield biodiesel and the glycerol molecules. The glycerol can be put to further use for soap production.
How would you write the conversion reaction from oil to biodiesel? Brilliant. There is a bottle of methanol on the handcart. Methanol is the simplest alcohol. It contains 1 carbon atom less than ethanol, which is the alcohol contained in alcoholic drinks.
Methanol is volatile and toxic. Make sure you work safely. You are ready to get started. The lab pad will guide you throughout the experiment. If you are not sure what to do, just click on it for more information.
Take a look at this image showing part of the methanol bottle's label. Which of the following hazards does not apply for methanol? You got it. Methanol is flammable, a health hazard, and toxic. We have to make sure there are no ignition sources when we are working with methanol. Make sure you are also wearing gloves and avoid breathing in toxic vapors. Pick up a pair of gloves from the handcart. Great, now you can grab the methanol from the handcart too. Enter the lab. Choose a workplace. Wait, Marie just told you that methanol is volatile and toxic. Volatile chemicals are easily evaporated. If you breathe in the methanol, you might get intoxicated. Methanol can lead to blindness or even kill you if you take up higher doses. Better go to the fume hood. The front of the fume hood is covered with a slidable glass sash. The fume hood constantly draws up the air and protects the user from toxic fumes. Make sure you keep the sash low, otherwise the airflow will not be sufficient to protect you. Also make sure to place hazardous chemicals to the back of the fume hood. Open the sash to safely work in the fume hood. Place the methanol bottle in the fume hood. Wait, that's not the ideal place to put the methanol bottle. Why? Exactly. If the methanol bottle is close to the sash, some of the fumes might escape. Better place it in the back of the fume hood. Place the methanol bottle in the back of the fume hood. There is something wrong with this workspace. Click on the problem. The person who used this fume hood before you has spilled a chemical. We need to clean this up before we start with our experiment. You have no idea what made this stain. Make sure you wear gloves before cleaning it. Pick a solvent on the handcart in front of the fume hood. There are 2 solvents to choose from. Drip the solvent onto the stain and remove it with absorbent paper. Acetone is an excellent organic solvent. In fact, it is so good that it can move right through your latex gloves. If you don't change your gloves, your skin will be exposed to acetone. Discard your gloves in the bin. Pick up a new pair of gloves. Before you conduct an experiment in the lab, you need to check the safety precautions and the health hazards for each chemical. This information can be found on the safety data sheet. Click on the View Theory button to have a look at the safety data sheet for methanol. Have a look at the hazard identification section by clicking the View Theory button. Which key sentence indicates why you should work in the fume hood when using methanol? Well done. It is very important to identify the hazards and precautions before you start working with a chemical. Methanol is toxic if inhaled. That's the reason why you have to perform this experiment in the fume hood. Methanol is volatile because it has a low boiling point. Have a look at the safety data sheet. What is the boiling point of methanol? Great job. The safety data sheet contains all important information about the chemicals. When you are working in the real lab, make sure you write the important information about the chemicals you are using in your lab journal. Add the methanol to the beaker on the heat plate. We need to catalyze the biodiesel producing reaction. A catalyst is a reagent that reduces the activation energy required for a reaction to occur but that isn't consumed in the process. In this case, we'll use sodium hydroxide. Pick up the sodium hydroxide. Well done. Sometimes chemical labels can be confusing because of synonym names or a different language. If you are unsure, you can always check the CAS number on the label and check in the safety data sheet if the CAS number matches with the chemical. Add the sodium hydroxide to the beaker. Now we need to dissolve the sodium hydroxide in the methanol. The heat plate contains a rotating magnet. If you add the magnetic stir bar to the flask, you can automatically stir it. Add the magnetic stir bar to the beaker and press start to mix the beaker's contents. It will take about 15 minutes to dissolve the sodium hydroxide in the methanol. Luckily, we are in a virtual lab so we can speed up the time and continue right away with the experiment. Add the algae oil extract to the beaker. Now we need to heat up the reaction mix to provide the energy for the chemical conversion. Do you remember the boiling point of methanol? Let's set the temperature around 5 degrees below the boiling point to make sure we don't evaporate the methanol. Set the temperature, then press the Start button to heat up the reaction mix. Why is it important to work in the fume hood during this step? Exactly. It is crucial that this reaction is performed in a well-ventilated area. Therefore, no sparks or open flames could ignite the methanol. Great work. It seems the reaction works. There are two phases forming. The biodiesel is at the top and the glycerol is below. Carefully pour the phase with the biodiesel into the empty bottle. Put the beaker back on the heat plate. Close the fume hood and go back to the center of the lab room.
Wow, I see that you were able to produce biodiesel out of the algal oil. This is super exciting. I will wash your biodiesel and perform some tests. In the meantime, please clean up the fume hood.
There is some remaining sodium hydroxide methanol solution that we have to dispose of. This solution poses several hazards. Which of the following does not apply for the sodium hydroxide methanol solution? Exactly. The sodium hydroxide methanol solution is flammable, toxic, and corrosive. Which of these hazards could be removed by adding small amounts of a certain solution? Good thinking. If we add enough weak acid to the solution, we can neutralize the strongly basic solution. Go to the fume hood on the right side of the room and click on the glass sash to open it. Pick up the weak acid for neutralization. Well done. Acetic acid is a weak acid. It's the main component of vinegar. Neutralize the sodium hydroxide methanol solution with the acetic acid. Well done. How should you dispose of the remaining methanol solution? Precisely. There are waste bottles for two types of organic solvents: the halogenated and non-halogenated solvent waste. Halogenated solvents contain halogen atoms such as chlorine, bromine, or iodine. Halogenated waste requires expensive treatment, hence, the two different types are separately disposed of. Discard your methanol solution in the right waste container. Imagine the two following scenarios. 1. You pour a small amount of non-halogenated solvent into the halogenated waste. 2. You pour a small amount of halogenated solvent into the non-halogenated waste. Which damage analysis is right? Precisely. Even if you only pour small amounts of the halogenated waste into the wrong container, the whole waste has to be disposed as expensive halogenated waste. Which of the following solvents would be disposed in the halogenated solvent waste? Well done. DCM contains chlorine, a halogen, hence it needs to be disposed in the halogenated waste. Close the fume hood and go back to the center of the lab room. React quickly. Great job. Maria's safe. What now? Use the circuit breaker to turn off all electrical. Well done. What now? Hey, great to see you again.
Hi, great to see you. I'm so lucky to not have been seriously injured. I think I'll need a new lab coat though. I passed out because of the blast. What happened after I was pulled out of the lab? That was a good call. Breaking the circuit turned off all the machines and decreased the danger of more damage. Why did you decide not to grab the fire extinguisher and fight the fire? Well done. I'm so happy that you left this dangerous task to the professionals. Fighting fires is very dangerous and you could have easily been injured while attempting to fight the fire. Especially the fumes of such fires are extremely dangerous. Great work. You are ready to work in the real lab, but let's hope you never experience such a situation in real life.
Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.